do most of it on your own. If you have any questions after I go over the review, of course, feel free to email me or message me on Google Classroom. I'm also going to be referencing my notes as we go. So I do have my notebook out. We are starting on page 25. It's going to be our first section here. So first thing we're going to talk about is degree, terms, and the name, like we're classifying them. So our first thing, our degree here is 1. Remember, anytime you have a singular variable, it really does have that exponent of 1 there. And then this is also a 1 term. So we're going to start with our degree. A degree of 1 is going to be classified as a linear polynomial, and if it just has 1 term, that's going to be classified as a monomial. So our answer for number 1 is a linear monomial. All right, our highest degree here is 2. We're going to have a degree of 2, and we have 3 terms. 1, 2, 3. 3 terms. So we're going to start with the name of the degree. If it has a degree of 2, it is a quadratic. And if it has 3 terms, it is a trinomial. All right, next up, we have a degree of 1. Remember, again, if you just have a singular variable, it has a degree of 1. But we do have 2 terms here, which means that it is going to be a linear binomial. All right. In our next example here, our highest degree is 4. Okay, and then the number of terms would also be 4. We have 4 terms here as well. So that's going to be a quartic. And anything greater than or equal to 4 terms, we just call a polynomial. All right, so all this stuff is on page 25 of your notes. All right, so I'm going to flip my notes page over. The next thing we're going to talk about is adding and subtracting polynomials. Remember, when you add them, you can just drop your parentheses. So we have 3x to the third minus 5x plus 9 plus 6x to the third plus 8x minus 7, and then we're just going to combine like terms here. So I have 3x to the third and plus 6x to the third. And remember, we just add the coefficients here, not the exponent. So the variable with the exponent stays the same. The sum would just be the coefficient sum. So we're going to end up with 9x to the third. Then we're going to combine negative 5x, positive 8x, okay? So it's easier to start with your positives. So if positive 8x minus 5x gives us a positive 3x. And then lastly, we will combine our constants here. We have 9 minus 7, which is going to give us a positive 2. All right, when we subtract, remember we're distributing this negative to everything in the second polynomial. So I'm going to rewrite it out here and then combine like terms. So we have 5x to the third minus 7x squared minus 8, and we're distributing. So we end up with negative 4x squared, negative 5x, and negative times negative, that's going to give us a positive 6. And now we want to combine like terms. So I don't see anything I can combine with this 5x to the third, so that's just going to be my leading term. We always want our highest degree at the front, so I'm just going to kind of cross that one out. We're done with that. We have negative 7x squared and negative 4x squared. So 2 negatives together, we're going to get farther into the negatives. It's going to give us negative 11x squared. Now we want to do this one next, because it still has a degree of 1. That's going to be higher than our constants. Constants always go last. So we're just going to bring this one over, negative 5x, and then we'll combine our constants last. So negative 8 plus 6 gives us negative 2 there. All right, next one, another addition problem. So we're just going to combine like terms after we drop the parentheses. 5x to the fourth minus 3x squared plus 4 plus 6x to the third minus 4x squared minus 7. We want to start with our highest degree, so that's going to be this one. That's going to be 5x to the fourth for our first term. We don't have anything to combine with this x to the third either, so this will just be our next term. So plus 6x to the third. Now we can combine these, so we're going to combine negative 3x squared and negative 4x squared. We're going to get negative 7x squared. And we can combine our constants here. So we're going to combine positive 4 and negative 7 to get negative 3. All right, one more subtraction problem. So we do have to distribute this subtraction sign or this minus sign, negative sign, to all of these different terms here. And I'm going to write mine underneath here because it's going to be a little bit longer. So we're going to have 5x to the third minus 7x squared plus 3x minus 4. And here's our distributive problem. We have negative 8x to the third negative 2x squared, negative 3x, and negative times negative is going to give us that positive 7 here. So now we have to combine like terms. We want to look for our highest degree. We have a 5x to the third minus 8x to the third. So it's going to leave us with negative 3x to the third. Then we have negative 7x squared and negative 2x squared, which is going to give us negative 9x squared. We have this positive 3x and this negative 3x. So when you have a positive 3x and a negative 3x, those are called a zero pair. They cancel each other out. Just kind of put some lines through those. We don't even need to write that. And then our last term here is going to be this negative 4 plus 7. And that's going to give us a positive 3. All right, so all this stuff, that's on page 26 of your notes if you want to go back and reference those. I'm going to turn my page. I'm going to be on page 27 for this next set here. And when you're finding perimeter, remember all you're really doing is adding. So we're just going to be adding all these together. I'm going to write it out here and then put equals and get my sum, and that's going to be my final answer. All right, so I have 5x minus 6 plus 2x plus 4x minus 3 plus 2x. All right, and then I'm just going to combine my like terms here, and that's going to give me my final answer. So I have 5x plus 2x plus 4x plus 2x. So these are all positive. 5, 6, 7. It's going to give us 11, 12, 13. So we have 13x, and then we'll combine our constants, which is negative 6 and negative 3 to give us negative 9. So 13x minus 9, that's our final answer there. All right, if you guys remember, when we did our first example on page 27, we saw some of these markings. So if it has one marking and one marking, that tells us that these two sides are congruent or they equal the same thing. So this side is 3x. If they have two markings and two markings, that tells us that these two are equal to each other. So if this is x, then this is also x. So we always want to label all of our sides first, then we can start to combine some like terms. So I'm going to start here, and I'm going to say 3x plus 3x plus x plus 2x plus 2 plus x. And there, I've got all my sides done. So I'm going to combine like terms, and that will give me my final perimeter. So 3x plus 3x, that's going to give us 6x, plus x is going to give us 7x, plus 2x gives us 9x, plus another x gives us 10x. So that's our first term. And then lastly, we don't have anything to combine with this plus 2, so we'll just tack it on to the end. So the perimeter there would be 10x plus 2. All right, next section, we're going to flip the page one more time. We're going to be on page 28. And this is multiplying polynomials, so product does tell us that we're multiplying. And I kind of gave you a couple of each example type that we did in our notes. So we're going to start with number 11, and this is just a distributive property problem. So we're going to have to distribute here and here. So when you distribute, you are multiplying. So we're going to multiply 3 times 4, and we're going to get 12. And when you multiply n squared times another n, that's like saying n times n, which is giving us n to the third power. Then we can't forget we're distributing to everything in the parentheses. So we have 3n squared times -1. Well, anything times 1 is going to be itself. So since it's times -1, it's just going to be the negative version of that. So we're going to tack on -3n squared. And that's going to be our final answer here. So we have 12n to the third minus 3n squared. All right, for the next one, you can do FOIL method or box method. So I will show both just in case you chose one or the other. So the first method I'm going to do is box method. So I'm going to draw a 2x2 box. I'm going to put my first one, doesn't matter where, I'm going to put my first one on this side today, 2x, and then +8. I don't really need the plus sign, but it helps me remember it's positive. And then I've got 4x, and I have to keep this negative with that 4, so -4. So now I'm just going to treat it like a multiplication grid. 2 times 4 is 8, and x times x is x squared. All right, -4 times 2 is -8, and then we have an x back there. 4 times 8, that's going to give us 32, and then we have an x, so 32x. And then we have 8 times -4, which is going to give us a -32. And we want to combine our like terms here. So our like terms are typically our diagonal ones here. We're going to start here and say that our leading term is 8x squared. 32 minus 8 is going to give us 24. It's a +24, and we keep our x value. And then we tack on our -32 on the end. So really one of the most important things about box method is that when you're combining these like terms, you are adding or subtracting them based on their sign. So no more multiplying when you get to that point. All right, so we're going to do FOIL method and see if we get the same thing here. Remember, FOIL stands for first, outside, inside, last. Okay, so I'm going to just rewrite here, 2x plus 8, 4x minus 4. All right, so first times first is going to give us that 8x squared. Outside times outside, so that's going to give us 2x times -4 is -8x. Inside times inside, so that's going to give us 8 times 4x, which is going to give us a +32x. And last times last, okay? So, oops, should be this way. Sorry, guys. There we go. Last, so we're doing 8 times -4 here. Last times last, which is going to give us that -32. All right, we want to combine our middle two terms here, so we should end up with 8x squared. That stays the same. 32x minus 8x is going to give us a +24x, and we keep our -32. So we did end up with the same answer for both. We end up with 8x squared plus 24x minus 32. All right, for our next one, we have to use this box method. FOIL doesn't really work when you do a binomial times a trinomial. You can still treat it like the distributive property, but I honestly think it's going to be a little bit easier just to do the box method for this one. And because of my space, I'm going to draw a 2x3 box. So my 3 is going to come out, and my 2 is going to go down. So 2 right here, and then 3 going this way. All right, so I'm going to put -2x here, +6 here, and then -x squared, +6x, and negative 7. I'm just going to fill in my boxes. So I have a negative times a negative here, which tells me it's got to be a positive. And then I've got 2, so my coefficient stays the same. X times x squared gives us x to the third power. All right, I'm just going to go straight across here. So negative 2 times 6, that's going to give us negative 12. X times x gives us x squared. Negative 2 times negative 7 gives us a positive 14, and we keep our x there. Positive 6 times negative x squared, so we have a positive times a negative, gives us a negative 6x squared. 6 times 6 is 36, and we keep our x. And 6 times negative 7 is going to give us that negative 42. So we want to combine our like terms. Typically they're going to be diagonal, okay? So we start with this first box. That's going to be our first term, 2x to the third. We're going to combine this negative 6x squared with this negative 12x squared. And remember, we're not multiplying, we are adding them. So negative 6 plus negative 12 gives us negative 18, and we keep our variable x squared the same. Then we're going to put these two together. So we've got 36 plus 14. That's going to give us 50, and it's going to be a positive 50. And we keep our variable the same. And then we don't have anything to combine with this last term, so we just tack that onto the end, negative 42. That's going to be our final answer for that one. So 2x to the third minus 18x squared plus 50x minus 42. All right, last one. This is a binomial, but it's squared, so we want to rewrite it in its expanded form, which is going to look like x minus 2, and then again x minus 2. So we're multiplying a binomial times a binomial. Again, you can use FOIL or you can use box method here. Either one is fine. Start by using box method. We've got x minus 2 and x minus 2. Make sure those negatives stay with the 2's. X times x gives us x squared. Negative 2 times x, negative 2x. X times negative 2, again we have negative 2x. And negative 2 times negative 2 gives us positive 4. Okay, we want to combine our diagonals by adding them together. So we start with our original, or our first box here. We've got x squared. Negative 2 and negative 2 do not cancel out. They give you negative 4x. And then we have a positive 4 at the end. If we do our FOIL method, we should end up with the same thing. So we're going to do first term times first term. It's going to give us x squared. We're going to do outside term times outside term, so that's this one and this one. That's going to give us x times negative 2, which is negative 2x. Inside times inside, so it's negative 2 times x, negative 2x. And then last term times last term. So this negative 2 times negative 2 is going to give us positive 4. We want to combine our two middle terms here, and we do end up with that same thing, x squared. This is going to give us negative 4x, and then plus 4. Please let me know if you guys have any questions at all. I'll be here. We can do some office hours this afternoon, or you guys can just message me on Remind or on Google Classroom, either way, and I'll be happy to help you out.